Today, we're going to be taking a look at Dia, which is from Nari Labs, a new text-to-speech system that has come out that allows for better prompting and more control over the AI text-to-speech. So you see here a Gradio interface. I have it up and running locally. It is a open source model, so you can get it up and running on your machine if you have the resources. And I'll play this sample audio that I have here, the output. So what I have is the audio prompt, a little bit of a transcription of the audio prompt, and then the text that I want to generate here. There are a little bit of quirks that I've been playing around with that I'll talk about. But yeah, let's play the audio sample that I generated from here.
Hunter, look at this hidden path we just found. This might lead to a hidden city that's been lost for 1,000 years. We should go check it out.
All right, so there you go. We've got these non-verbal tags like clears throats. So we've got laughs, haha, and those are pretty unique. We don't normally see this type of tagging in text-to-speech or these text-to-speech engines that have been released recently. We have some of this control that you can do with GPT-Sovitz. I still think GPT-Sovitz sounds very great, very natural. But this Nari Labs with Dia seems to be pretty good too. So we're going to take a look at the repository and just go over it a little bit. Not going to be a installation video, but more of a showcase of this. And what I just showed you was a fine-tuned model of the Dia model, and show how you could probably try to get this set up. But, or not entirely set up, but like I said, how you might be able to get through this if you're familiar with scripts and GitHub repositories. If you want an installation video, I can do that, but just, comment down below. All right, so we have an example page. If we go to the not the Discord, but the GitHub page here, it leads us to this page where we can find some of the output examples. They tested it against 11 Labs and Sesame CSM. So I'm going to play it for this input script here, and we'll take a listen to it. So Dia first, 11 Labs, then Sesame.
Dia is an open weights text-to-dialogue model.
You get full control over scripts and voices.
Wow, amazing.
Try it now on GitHub or Hugging Face.
Dia is an open weights text-to-dialogue model.
You get full control over scripts and voices.
Wow, amazing. Haha.
Try it now on GitHub or Hugging Face.
Dia is an open weights text-to-dialogue model.
You get full control over scripts and voices.
Wow, amazing. Haha.
Try it now on GitHub or Hugging Face.
Okay, so out of all of those, Dia to me sounds the best. Now, they do note that they had to change out these nonverbal tags like laughs with haha because the 11 Labs and CSM don't naturally support these tags so far as we know, or so far as I know. And yeah, it sounded very great. We've got another example here that I'll show. This is going to be a, I think this is a voice cloning one. So let's see.
Hey, how are you?
Okay, no, not that one. I think they have, oh, here we go, audio prompt. So this is going to be kind of like the voice cloning one. So you've got the transcriptions, and then you've got the text to be generated. So we'll take a listen to this real quick.
Open weights text-to-dialogue model. You get full control over scripts and voices.
So those are the two alternating voices, and we can hear the continuation prompt.
I'm biased, but I think we clearly won.
Hard to disagree.
Thanks for listening to this demo.
Try it now on GitHub and Hugging Face.
If you liked our model, please give us a star and share to your friends.
This was Nari Labs.
So there you can hear that you can also specify two different speakers here as they have done so. And then you can just annotate which speaker in this audio prompt it is. So you've got the female voice here and then the male voice for... So you got the female voice for the speaker 1 and then the male voice for speaker 2. Now we've got this other example. We'll go over this fun example. We've got a little bit of an explicit in here, but we'll go ahead and play it. We're not afraid of bad words here. And we'll take a listen to it. So Dia, 11 Labs, then Sesame.
Oh, fire! Oh my goodness! What's the procedure? What do we do, people? The smoke could be coming through an air duct!
Oh my god, okay. It's happening. Everybody stay calm.
What's the procedure?
Everybody stay fucking calm. Everybody fucking calm down.
No! No! If you touch the handle, if it's hot, there might be a fire down the hallway.
Oh, fire. Oh my goodness. What's the procedure? What do we do, people? The smoke could be coming through an air duct.
Oh my god. Okay, it's happening. Everybody stay calm.
What's the procedure?
Everybody stay fucking calm. Everybody fucking calm down.
No. No. If you touch the handle, if it's hot, there might be a fire down the hallway.
Oh, fire. Oh my goodness. What's the procedure? What do we do, people? Good, no. The smoke could be coming through an air. I know. Well,
Oh my god. Okay. It's happening. Everybody stay calm.
what's the procedure?
Everybody stay fucking calm. Then
No. No. No.
Okay, so in terms of quality, Dia and 11 Labs were Dia was the best. 11 Labs fidelity wise sounds better, but it doesn't flow as nicely. And then Sesame CSM was just funny. Like I just thought that audio piece was funny. But as you can tell, it does very well, and you can try this out if you go to the GitHub repository and follow the instructions here. So I got this all set up, and we'll go through that real quick. So we'll go into cursor here, and I already have it running, but I'm using my fine-tuned model here. So I'm just going to use the base model for the first demonstration, and then I'll show you my fine-tuned or the fine-tuned model. And we'll just go ahead and launch that. So the cool thing is, if you are familiar with setting up GitHub repositories, is they are using a new tool called UV, which is awesome because all we need to do is just do UV run app.py, and it's going to set up the entire virtual environment for us, and it's going to be all version controlled. So we should be able to just duplicate the environment and get it up and running on our machines pretty easily. And that's the power of UV. Or else you could set it up manually with pip. But I don't know why you'd want to do that. It makes your life a little bit harder. Switch over to UV. It works really well. I'm going to do that for all of my projects from here on out. But it looks like I got to download the model. So just give me a moment. Already. And it finished downloading. So we can now go and use it. So I'll open up a new page real quick. Let me just duplicate this. So we've got the interface here, and I'm just going to generate audio with the base model. And what it's going to do is it's going to grab some randomized voices for speaker 1 and speaker 2 and generate based off of that. So the inference time for this, it can be up to real time, but in my observation with this base model, it seems to be about half real time speed. So I could be doing something a little bit wrong here, but all right, we've got the output. So we can go in here. So it says it took 26 seconds for about 9 seconds of audio, which is a little bit under half real time, but I believe I had to load some models for this. But let's just take a listen to this.
Dia is an open weights text-to-dialogue model.
You get full control over scripts and voices.
Wow, amazing.
Try it now on GitHub or Hugging Face.
So there you go. That sounds pretty good. The alternating speech is great, and we can try it with their example prompt here. So like I said before, you got the transcription, which is the audio prompt.
Open weights text-to-dialogue model. You get full control over scripts and voices.
And then the rest of it is speech that you fill in. So we're going to generate some audio with that. And it says it's going to take about 27 seconds for that. Yeah, we go into here, take a look at what it's doing. Well, we don't have too much debugging inside of the terminal here, but go back here. We can, while it's finishing up the generation, let me just scroll real quick to the little tags area, and these are the different tags that you can try out. I don't know if there is going to be a little bit more tags, but yeah, these are the tags that you can use. You got like laughter, clears throat, sighs, gasps, coughs, yada yada yada. All of these different tags you could try out. I won't go through all of them today because that's going to take a little bit of time. But yeah, we've got the audio here, and that took 28 seconds. So the GitHub page says it's about 1x real time on a 4090. I don't know why my speeds are so slow, but regardless, let's take a listen to this example.
I'm biased, but I think we clearly won.
Hard to disagree.
Thanks for listening to this demo.
Try it now on GitHub and Hugging Face.
If you liked our model, please give us a star and share to your friends.
This was Nari Labs.
So there we go with that. As you can tell, we'll listen to the audio prompt one more time just to hear the cloning.
Open Waits text-to-dialogue model.
You get full control over scripts and voices.
So it's close. The male voice is much deeper actually in the outputted audio here, but it's pretty good. And then that is what fine-tuning would be for. So let's just try a few different tags here before we jump into my fine-tuned model that I did on one character. I haven't done a dual character data set yet. That's the next thing I want to try. And let's maybe add a clears throat instead. Hard to disagree. Clears throat. Thanks for listening to this demo. Do gasps. And then we'll do singing, see what comes out of that. And this is awesome because this is kind of something that I've wanted for a while, to where you could specify these nonverbal tags for things like laughter, sighing, clearing throats. It just makes it much more controllable. I know GPT Sovitz does allow for that a little bit, but it's not as explicit as I'd like. So here we go. Let's take a listen.
I'm biased, but I think we clearly won.
Hard to disagree.
Thanks for listening to this demo.
Try it now on GitHub and Hugging Face.
All right, so it skipped the last two sentences. I don't know what happened with the singing section. It must have thrown a stop token in there because it didn't do the rest of it, and I don't know what that was. We got a little bit of pentatonics at the end there, but yeah, let's go ahead and jump into the fine-tuned model that I have just to show how speaker cloning works. Or actually, before I do that, I want to show the character that I trained on inside of the base model and just compare the two. So I have a what did I use here?
3 clan.
Okay, I used this. Let me find this.
You can 3
Okay.
clans vying. Incredible.
All right, so we've got that. Let's trim it. And that's the 5-second section that I used. And I'm going to use the same prompt that I used for the fine-tuned model versus the non-fine-tuned model. So I'll use the same generation settings too. So 3060, 1.595, 1.5. I mean, what sucks is that I don't have a seed in here, so it's not going to be an exact one-to-one, which I wish it was. But gonna generate audio for this. So what I'm doing here is I'm doing speaker cloning, and I've got this audio prompt here, which is Alma from Monster Hunter Wilds, and then I've got the transcription of it with this first sentence, and then the rest of this is the text that I want to generate. So here it is. Let's take a listen to it.
Hunter! Look at this hidden path we just found. This might lead to a hidden city that's been lost for 1,000 years.
Cheater.
We should go check it out.
So there you can hear, other than that S2 tag, that it sounded decent, but the cloning wasn't as accurate. So for example,
3 clans.
That's how Alma sounds, and
Hunter! Look at this hidden path we just found.
it is this speaker is a little bit, I'd say, has a little bit of a deeper voice, I think, versus this sentence here.
Hunter! Look at this hidden path we just found.
It sounds a little bit closer to Alma's voice.
3 clans vying with each other since.
So that's the fine-tuned model that I have, and the way that you do fine-tuning is very similar to Tortoise, which is awesome because we don't need to do too much more of a different type of dataset preparation. I can use some of the scripts that I made in the past for Tortoise to make datasets for Nari Labs Dia, which is great. And what should I show next? Oh, one thing that I did want to go over is like these S2 tags, why I have this S2 here for the fine-tuned model. So in order to get the fine-tuned model up and running, let me stop this script and then continue with changing up which model we load. So I have to load in the model from a local checkpoint, which I need a configuration path and a checkpoint path, which you get from fine-tuning. And then I can relaunch this script here, uvrun app.py, and it's going to load this fine-tuned model. And then we can just use the Gradio interface. Not necessarily the most friendly yet for loading and unloading models. We should be able to control all of that inside of the Gradio interface to make things a little bit easier. But yeah, I think it's currently just a demo state, not necessarily a full-on inference GUI with all of these different controls, just more of a demo on this model. We'll go ahead and refresh that. Now I can go ahead and remove this, and we can generate audio with the fine-tuned model. And so we don't even need to have an audio prompt in here to get an output audio that sounds similar to the speaker that we fine-tuned on. So that is great, but I do recommend that the audio prompt is added because it makes the similarity much closer. So let's take a listen.
Dia is an open weights text-to-dialogue model.
So it does sound very close to Alma. It is female. But if we wanted it to be a little bit closer to Alma, we would need to have that audio prompt in here. So I want to go over why I have this S2 tag in case you guys want to try it out. For whatever reason, this S2 tag seems to kind of be a like an end of speech token indicator for the model, at least with this fine-tuned model, to not get weird cutoffs at the end. So let's take a listen to this.
Dia is an open weights text-to-dialogue model.
So that one didn't have that loud cut like the previous audio. I'll take that out again, and then I'll regenerate the audio with that. And all right, let's take a listen.
Dia is an open weights text-to-dialogue model.
All right, so maybe not, but in my observation, adding that S2 tag helps out quite a bit. This one didn't have that sharp cutoff at the end, but based on my tribal knowledge of testing it out so far, you do need that tag. And then we can try this out here, generate audio. And I will modify a few of these tags just to try it out with other tags. And then I'll just go over a little bit on how it was fine-tuned. Nothing too crazy, nothing too in-depth, just kind of a process that I followed in case you guys are tinkerers out there and want to kind of get this set up yourself. It'll give you a starting point on what to do. So the, what is it? The output is taking quite a little bit of time for this one. Like I said, I think they claimed 1 times real speed without compile, which it's not compiled on float 16, 1 times real speed, but I'm not getting that. But okay, here we go. Let's take a listen.
3 clans vying with each other since days of yore to create something incredible? Hunter, look at this hidden path we just found. This might lead to a hidden city that's been lost for 1,000 years. We should go check it out.
Okay, so it sounds good. Like in terms of just like the laughter, the clear throat, obviously fidelity wise, I think it's a little bit lower quality or lower fidelity that I would have wanted, but we could probably use something like super resolution from that APBWE repository from the other videos to increase the quality output of it. I have to try that out, but didn't get time for that for this video. We can try a different tag here. I just deleted that other part because that's the transcription. We can try some other tags. So let's try out maybe sniffs. And then let's try coughs. I could probably just type this out. Coughs. And then let's generate audio here. And yeah, after this, I'll go and just go over my process that I did for fine tuning, and then that'll be pretty much it. If you guys want more information or want me to go in depth a little bit more on this, always feel free to comment. Let me know what you guys would like to see, and I'll try to get around to covering it. But yeah, we've got this up and finished. Let's try it out.
Hunter, look at this hidden path we just found. This might lead to a hidden city that's been lost for 1,000 years. Oh, we should go check it out.
All right, so speaker similarity there was next to Nye, and not too certain what happened there. Let's try to regenerate the audio and see if we can get it back to Alma's voice. And if not, then the audio prompt probably would be highly recommended. I think when they trained it, they said they didn't train it on any speaker. Note that the model was not fine-tuned on any specific voice. So even though I fine-tuned it, it probably still just grabbed a voice from the training data and used that instead. So let's try this out.
Hunter, look at this hidden path we just found. This might lead to a hidden city that's been lost for 1,000 years. We should go check it out.
All right, so that audio out there, this audio actually sounded really good. And it did the sniff, it did the cough. So that was cool. Now, before I jump into fine tuning, real quick, just want to go over some other things that I was looking at or found out or, basically just read. So they said that this work was inspired by Soundstorm and Parakeet. It seems mostly the architecture flows from this Parakeet model, which was actually released last year, May 12th, 2024, as it follows kind of like the same S1, S2 annotation, these nonverbal tags. And I didn't look into it too much, but it seems like Nari Labs Dia is heavily inspired by this paper here. And they are going to do a write-up for this, so it'll be interesting to see what that write-up is, but no paper on this one yet. Now, okay, let's jump into the fine-tuning part. So there is a fine-tuning script that you can run and use from one of the creators, which is from STL Array, and it gives you the whole pipeline. So we don't really need to even do too much, and we can just install it. So if you know how to use UV, all we actually have to do is just do UV sync, and I think that will get us the environment that we need. So this is the repo right here. So it's got a UV lock. All we would need to do is git clone that repository. So saying you did that, we just need to do something like UV sync, and it would set up our environment that we need in order to train. And then for training, all we need to do is run this usage example here. And the way that I did it was with this one right here. So UV run module dia.finetune CSV path train.csv audio root. This is where the data is. So Alma for the audio files. The hub model, which is the base model, which was this Nari Labs Dia 1.6. Run name is Alma experiment, and then output directory is this Alma checkpoints. So that is what I used to run the training in this repository once I had the environment all set up. And then if you wanted to continue from a checkpoint, you could just run. I ended up using just Python in this case. So if you want to just use the Python command, you need to activate the .vnv environment. So I ended up just doing a Python call, basically all of the same stuff. The only thing I changed was local checkpoint, Alma checkpoint state to be the 1200th checkpoint that I had here. And then everything else for the most part is pretty much the same. So those are the two commands that I use to start the fine tuning run. And then the way that you need to set up the data, follows a specific format, but it's the tortoise format for the most part, if you're familiar with training tortoise TTS. So the first audio column, or the first column is going to be your audio path. So if we did something like this, it's going to be audio, or what is it, like path or audio, basically audio name. And then you have your bar, and then you would do some type of speaker tag, speaker 1, and then the transcription would be this second column. So the second column includes the speaker tag with the transcription, and then the first column is just the name of the audio file. So most likely it's just going to be audio_name.wave, something like that, because you specify the audio root already here. So for example, I'm doing Alma. If I had an audio file here, the script will find it at Alma/audio name. So you don't even need to add the dataset name into here for it to run. Now, a few things: you want to make sure that your dataset doesn't have any audio files that are below a certain length. So you want to make sure that your dataset size, or if you sort by size, you want to make sure no audio files are, I'd say, below 60 kilobytes. If it's a WAV file, you want to make sure that they have enough audio, so you're not getting like any, well, this will it'll cause issues if you try to train, because the audio files are too small, and so it starts trying to do operations on like 0 size tensors. Okay, and I think that is it that I need to go over. But that is a very, the explanation that I did already kind of hopes that you guys are familiar with getting this stuff set up. So if you want to see something a little bit more in depth, let me know, and I'll try to come up with something. Yeah, I have a dataset maker that I use for this. I haven't uploaded this to GitHub, but I'll probably do that sometime. I don't know. We'll see. We'll see when. But yeah, that's all I wanted to go over. Dia TTS from Nari Labs. Cool new model out there. And once again, if you remember the channel, thank you so much for supporting me. Very much appreciated. And I will see you guys later.